morning, students. Welcome back to mathematics class. Dear students, in last class we discussed about the exercise 5.1. So today I will continue the exercise 5.1. I already solved the question number 1, 2, 3. Now I am going to solve the question number 4. Prove that the function f of x is equals to x raised to n is continuous at x is equals to n, where n is a positive integer. So let us consider solution. Let us consider the given example. Let us consider f of x is equals to x raised to n. So for the checking the continuity of the function f of x is equals to x raised to n, it is a single function. Just we have to use the identity or the formula, that is we already familiar about that. X limit as x tends to c, f of x is equals to f of c. Here c is nothing but n. Here c is nothing but n. Therefore, so first of all, limit as x tends to n. So when the function is f x raised to n. Now taking limit, it means put the value of x is n, because the limit is approaches to the n. Therefore, this is equal to n raised to n, because when you put the value of x is n here, it is a n raised to n. Similarly, we have to check. We have to check f of n. That is nothing but the function is in place of x put n. F of n is equals to n raised to n. Therefore, limit as x tends to n, that is x raised to n is equals to f of n is equals to n raised to n. Therefore, the function f is continuous at x is equals to. Students, see here, when the function is f of x is equals to x, it is nothing but is a identity function. For any value of x, you get y. Means if x is equals to 1, you get y is equals to 1. If x is equals to 1, y is equals to 1. If x is equals to 0, y is equals to 0. If x is equals to minus 1, y is equals to minus 1. If x is equals to minus 2, y is equals to minus 2. If x is equals to minus 3, y is equals to minus 2. So likewise, you get the function is identity function, but the value of the x is less than 1. For the values of x is less than 1, you get the graph like this. This is the identity function when the function x is less than or equals to 1. And what happens when the value of x is greater than 1? It is a constant here. See here, f of x is equals to 5. It is in the form of f of x is equals to c. So you already familiar about the constant function. This is a constant function. For any value of x, the function is remains constant. The graph is like this. You can draw this graph without lifting the pen. The thing is, the function is continuous less than 1 and greater than 1. So the function is less than 1, less than or equals to 1, the function is identity function. For the value of x is greater than 1, the function is constant function. But thing is, here the graph is break here. It is a breakage. Where it is breakage? At exactly 1, the function is breaks here. Hence, we can't draw the graph without lifting a pen or a pencil. Hence, this graph is a discontinuous graph. The function is a discontinuous at exactly at x equals to 1. But x is less than 1 means at 0 the function is continuous here. See here, the function is continuous. For any value of x is less than 1, from here to here, see here, for any value of x is less than 1, the function is continuous. Okay. So they asked, check the continuity of the function at x equals to 0. See here, the function at x equals to 0 is continuous here. At exactly 1, it is discontinuous. And what happens when the function is the value of x is greater than 1? X is greater than 1. For any value of x is greater than 1, that is 1.5, 2, 3, 4, 5, etc. The function is continuous. So less than 1, greater exactly at the value of x equals to 1, the function is discontinuous. Okay, so this is the graphical representation of the continuity of the function. So now I am going to solve the example. But how we can solve the example? Okay, see. For the continuity of the at x equals to 0, here we already remember here the function is at x equals to 0 is a continuous. Hence we prove here. So for the example, for the value of the function x is less than 1, that is x. That is, so we check for both the limit, left hand limit and right hand limit, and also the value of f of c. We know that the formula f of x tends to c minus n equals to f of limit as x tends to c plus equals to f of c. So I already told you we use this formula when the function is in a pieces, means more than one function. We use this formula. So here first one LHL is equals to limit as x tends to 0, because we are checking the continuity of the function at x equals to 0. So hence this is a 0 minus left hand limit, that is f of x. What is f of x here? So we can write this as a x tends to c minus f of x. So limit as x tends to 0 minus the function is less than 1 means that is a x. Taking limit here means taking limit, put the value of x equals to 0 here, because the limit is 0 here. This is LHR. The value of LHR is 0. Similarly, RHR, this is nothing but limit as x tends to c plus is a f of x. So this is also limit as x tends to 0 plus, because we are checking the continuity of the function exactly at x equals to 0, and this is a 0 plus. 0 plus means that the value of the limit moving from right towards the limit, from right to towards the limit. Negative sign indicates from left to the limit, like this. You already learned about you studied in the first page. So this is also in the function is same, that is the x. So this is by taking the limit, that is also 0. This is the RHR. And check the continuity, the value of f of 0. So the symbol is equal to here, is equal to existing here. On that occasion the function is x. Therefore we can write this as f of x is equals to x. Therefore f of 0 is equals to 0. Therefore this function at x equals to 0 obey or satisfy the condition, this condition. Therefore limit as x tends to 0 minus limit as x tends to 0 plus equals to f of 0 equals to 0. Therefore the function is continuous at x equals to 0. See here, the function at x equals to 0 here. Is there any breakages here? No, because if the breakage is like this, is there any hole here? No, there is no hole like this, because here it is a breakage. This is discontinuous here. It has a break here. Okay, continuous function means we can draw the graph without lifting the pen or pencil. If the function we can't draw the graph like this, so can we draw the graph here at one speed? It is impossible. Such graphs are called as discontinuous graphs. Now check the continuity of the function at x equals to 1. At x equals to 1. At x equals to 1. So we know the identity already. I will apply the directly formula. Left hand limit as LHR is equals to limit as x tends to c minus, that is the f of x. Limit as x tends to 1 minus, because limit is 1 here. On that occasion the function is at exactly, that is the left hand limit is x, that is x. Taking limit, put the value of x equals to 1. This is 1. LHR is equals to 1. Similarly RHR is equals to limit as x tends to c plus f of x. So that limit as x tends to 1 plus, on that occasion the function is 5, because x is greater than 1, the value of the function is 5. This is the 5, because the value of the greater than 1 means 1 plus the value is 5. This is RHL. Therefore here LHL is not equal to RHL. LHL is not equal to RHL, because LHL is 1, RHL is 5. Hence the limit does not exist. Limits does not exist. Does not exist. So it is not necessary to find f of c. It is not necessary to find f of c if the limits LHL is not equal to RHL. It is not necessary to find f of c. Once the limits exist, and we move forward to the find f of c. So if LHC is not equal to RHL, hence we stop here, and limit does not exist. Hence, therefore, the function is discontinuous at x equals to 1. Here the function is discontinuous here at x equals to 1, because x equals to 1 the function is breaks here. So that is why the function is discontinuous at x equals to 1. Okay, x equals to 1. Similarly, to find the continuity of the function at x equals to 2. At x equals to 2. Here, LHL is equals to limit as x tends to 2 minus, because limit is 2. On that occasion, the function is for x is greater than 1 means x is greater than 1 means the value of x is 2. At x equals to 2 means we consider the function which is x is greater than 1. On that occasion, when x is greater than 1, the function is 5. That is a 5. Hence, its value is 5. LHL. Similarly, RHL, this is equals to limit as x tends to 2 plus, here also the function is same, that is a 5. Therefore, now f of 2 is also, that is a 5. F of 2 is 5. Therefore, because f of 2 means since it is a constant function, at x equals to 1 the function is 5, at x equals to 2 the function is 5, at x equals to 3 the function is 5. Hence the f of 2 is also 5. Therefore, limit as x tends to 2 minus is equals to, limit as x tends to 2 plus is equals to f of 2 is equals to 5, because all three terms equals to same. Hence the function is continuous at x equals to 2. So that this is the continuity of the function f of x at x equals to 0, at x equals to 1, and at x equals to 2. Thing is, the function is only discontinuous at x equals to 1. Okay, thank you. Dear students, so I am going to solve the next question of exercise 5.1, that is the fifth question. Is the function f defined by f of x is equals to x if x is less than or equals to 1, 5. If x is greater than 1, the value of the function is x if x is less than 1, equals to 1. And the value of the function is 5 when x is greater than 1. And also they asked check the continuity of this function at x equals to 0, at x equals to 1, and at x equals to 2. So I draw the graph of this function is like this here. See here, it is not necessary to draw the graph in the examination. Okay, just for your understanding, only I will draw here the graph. Okay, see here, what happens here? when the value of the x is less than or equals to 1, the function is, that is identity function, because this is nothing but it is in the form of like this. F of x is equals to x means y is equals to x. For any value of x, you get the same number. Means if you put x equals to 1, you get y is equals to 1. If you put x equals to less than 1, means the value of x is less than 1. For any value of x less than 1, the function is identity function. For 0, you get 0. For minus 1, you get y is equals to minus 1. For minus 2, you get minus 2. Means for any value of x is less than or equals to 1, exact 1 is equals to 1. Less than 1, 0 is equals to 0. When the value of x is minus 1, you get y is equals to minus 1, minus 2, minus 2, minus. Similarly, the graph of the function is like this when x is less than or equals to 1. And what happens if f of x is equals to 5? This is nothing but a constant function, means f of x is equals to c. So you already aware of the constant function. See here, this is the graph. So this is constant function. This is the graph of the function. For any value of x in the domain, you get the function is continuous, but here we got constant function. Okay, this is a c. That is f of x equals to c. C means here 5. For any value of x is greater than 1, x is greater than 1.